Looked at 1,000 stations in the United States that came from very small towns, averaging no more than about 5,800 people. And we looked at the temperature pattern from those cities over this century. We found out that most of the United States has cooled this century, not warmed.
Furthermore, new data from space has made the land record more doubtful. Until recently, we've had no alternative but to rely on thermometers and weather balloons. But now, for the first time, satellites are giving us another source of information. Dr. Spencer at the NASA Space Center has been able to analyze satellite data to produce snapshots of global temperature, each one equivalent to tens of thousands of separate thermometer readings taken by hand. In February of 1983, the hottest areas are clearly visible over southern Africa and Australia, while in August, the warm areas shift into the northern hemisphere.
We've found that we can monitor globally averaged atmospheric temperatures with a high level of precision, even on a monthly basis. We're estimating the precision at about 1/100th of a degree per month.
Unlike the thermometer data, the satellite information is evenly spread and does not suffer from the urban heat island effect. Over the last 10 years, the thermometer record has shown an underlying upward trend. But according to the satellite information, the Earth was rather warmer in the first half of the 80s and rather cooler in the second half.
The trend in the thermometer data is only about 1 to 2/10ths of a degree, which doesn't sound like much. But it's enough to be a significant difference with the satellite indication of no trend. Over the entire 10-year period of time, there was no net warming or cooling.
For the first time, satellites have given us an alternative to the land-based data, but they show no increase. So there's a flaw in the first pillar that supports the greenhouse theory. The urban heat island effect and the satellite information point to question marks over the data on which claims of warming have been based. But even if we accept the thermometer data as accurate, whether there's been a temperature increase or not depends on the timescale you choose. Would you accept that over the last 10 years there's been no overall increase in global temperature?
No, I wouldn't accept that. But that is a question that may be irrelevant in the greenhouse context. The greenhouse effect is a century timescale warming.
The warming Professor Wigley is referring to comes from this graph of temperature over the last 100 years, which shows an underlying increase of 0.5 degrees Celsius. The problem is that the trend depends on the period you choose to examine.
If you started it someplace else, if you ended it at someplace else, the trend changes. And so it's clearly not a record you draw a straight line through and say this is warming.
You mean that if we took the last 50 years, then it would tell a different picture?
Yes, absolutely. Last 50 years, it does nothing. Went down and then went up.
And if we chose the years from 1930 to 1970, the average temperature actually falls fairly sharply. We don't have the data to extend the graph backwards much beyond the last 100 years, but there is evidence that there have been times when it's been warmer than it is today. Medieval records show that vines were grown throughout Britain, and remains of a beetle, a species of nettlebug, has been found in York 1,000 miles north of its current habitat in the Mediterranean. So if we had thermometer records going back for 1,000 years, it could well show a fall in temperature since then, rather than a rise. Doubts over the data and problems with the time base have led Dr. Idso, who studied the effects of carbon dioxide on climate for the past 20 years, to be dismissive of claims that the world is warming.
Some people claim that there may have been a 0.5 degree centigrade warming over the last 100 years. This is really tenuous. If you look at the real world, let's say over the past 100, 150 years or so, and you find that there has been no significant warming.
But perhaps more than global temperature rise, it's been predictions of increases in sea level that has encouraged impressions of impending catastrophe. Entire cultures are apparently faced with disaster.
As the children play, year by year the waters are rising around them. They'll be adults by the time the Pacific swamps the 9 sandy studs that are the islands of Tuvalu. If forecasts are correct, the seas round here will rise by about 2 feet over the next 50 years.
It's not only the media. The scientists themselves are not averse to making the situation appear dramatic. Steve Schneider is one of the United States' leading global warming theorists.
If the sea level rises, and those projections range anywhere from a few tens of centimeters to maybe a meter or so in the next 100 years, that by itself is not that serious except to places that are low-lying, the Maldives and Venice and probably London. But what really is serious is if the warming of the oceans causes an increase in the energy source for severe storms, then you get a higher probability of more intense hurricanes or other severe storms driven by ocean evaporation.
That's particularly important in a country like Bangladesh, where there are tropical cyclones that even today kill many thousands of people. In some parts of the world, I think there's very strong reason to believe that the consequences would be severe.
But as with temperature changes, the facts about sea level rise tell a different story. The Oceanic Institute near Cape Cod, 250 miles north of Manhattan, is one of the most influential organizations studying the sea. For many years, Dr. Aubrey, who heads coastal research at the Institute, has traveled the globe investigating changes in sea level. Can you tell whether the sea level has gone up or not over the last, say, 100 years?
No, we can't unambiguously say exactly how much the ocean has risen over the entire globe. Some tide gauge stations show the sea level rising over long periods of time. Others show sea level falling during other periods of time. The problem is that the land is also moving up and down. In some places it moves up considerably fast, in other places it falls, it subsides fairly fast. So you're measuring the sea level against another level that's moving up and down. And that leaves you with a lot of uncertainty about how much the ocean is moving versus how much land is actually moving. If you look at the British Isles, you see the same thing in a very small portion. The northern part of the British Isles, sea level is falling. South part, the sea level is rising. In the past, people have averaged different sets of tide gauge records, and they've averaged those tide gauge records for different periods of time, say from 1930 to 1960 or 1910 to 1980. And every time you take a different set of stations and a different set of dates, you can come up with whatever answer you want, in effect. I think on a time scale of the past 100 years, the errors are so great in trying to estimate what the global sea level is doing that we cannot come up with a useful answer that's going to be usable for predicting what sea level may do in the future.
We may not be able to predict what will happen in the future, but Dr. Aubrey has no doubts about the evidence so far.
There's no evidence that sea level rise has accelerated due to global warming.
While direct measurements have been unable to confirm that sea level is rising, in 1989 there appeared to be evidence of sea ice melt. When submarines passing under the North Pole reported that the ice at specific points was less deep than it had been 10 years earlier. But Julian Parran at the British Antarctic Survey is sceptical.
Just 2 snapshots of Arctic sea ice 10 years apart, even if it did indeed show a thinning, wouldn't really be significant compared with data taken from long-term monitoring of sea ice extent.
The submarine observations are contradicted by the only reliable evidence coming once again from satellites, which for the last 12 years